Hey Rick, how are you doing?
Hey, how you doing?
Yeah, pretty good. All right, let's see over here. Hmm, Share screen. Okay. Okay. All right, let's start with questions. Any question related to what we discussed last week?
No questions.
All right. So today we are going to do logistic regression, and I think it comes maybe in module 3 or so. So it will, we'll get it covered over there, and then we have like other stuff like nearest neighbors and trees and PCA and all that stuff coming up. But let's go ahead and check out logistic regression. Let's see over here. Okay, we go and that's fine. Okay. So logistic regression, what we learned last time also a little bit was that it was more about categorization, or also known as uh, classification. I don't have the, let me go ahead and write it again. Classification, classification. So unlike linear regression that is going to predict the price of a car or a price of a house, the logistic regression or logistic classification, I think it's called logistic regression. Sorry, logistic, let me go ahead and see over here. Logistic regression. Logistic regression is going to be finding out the class of something. So that means that you may end up with some points on a scatter plot in in such a way that these cannot be used in a linear regression. So what happens is that you kind of like divide it into two, and this is cat, and this can be a dog. So basically, two classifications. So it's a really good way to classify things, meaning it can read a bunch of text and it can classify on a set given categories. Like it can classify that, oh, the text, like 5 lines of text that I just read, it looks like it's a news from a finance industry. Or the 5 lines that the text that I read, it looks like it's a news from some NBA game that I watched. So logistic regression is all about categorization or classification. All right. Now, I think there are a lot of ways that you can classify things. Let me actually see if I have this create ML. This is something that is in iOS, so you're probably not going to see this on your machine. But I just wanted to show you this just for so that we have a little bit of idea of classification. All right. You see this first one? I mean, there are so many different options, but the first one is saying image classification. So image classification over here, and this program is called Create ML. It's only available on Mac, so you won't be able to see it on your PC, but we can definitely like kind of like try to see what happens if we classify something. Now, in order to classify something, you need the data. Without the data, well, you can't really classify anything. So let's go ahead and try to see if I can get, let me actually go to my GitHub, I guess. That might be a much better option. So what I want to do is I want to classify cats and dogs. So I'm trying to access the data over here. Classification. I wonder where is the image classification starter project, cats and dogs. Yeah, there we go. This might be a little bit big. Let's see. Okay, 68 megabytes, not that big. So in order to classify cats and dogs, because some images will be cats and some images will be dogs, we need to train it. meaning we need to use some sort of an application that can train, that can learn that these images are cats and these images are dogs. Now you can see I'm actually not at my home office, so it's a little bit slow to download. So how does it know which ones are cats, which ones are dogs? Well, the good thing is that when we're using this on Kaggle, this particular data set, they have already done the job of creating a separate folder for the cats and separate folder for the dogs. So that kind of helps us out. So we have structured data now. So if I go ahead and check out the data, should be over there, this one. So you can see that we have two folders. One is test and train. I think we want to use the train. And in the train, let me actually move this into the screen over here. Now, if I open up the train, you can see that somebody has already organized cats into cats folder and dogs into dog folder. So if I open up cats folder, I see all these images of cats, right? So somebody has already done that job of organizing it, and dogs will obviously have dogs. And there are quite a bit of images, as you can see, probably more than 100, I would guess. So somebody has already done the work of organizing cats and dogs. What we are trying to do is we're trying to create a model that can recognize, if I give the model a new image, it can tell me, oh, this is a cat or this is a dog. Now, again, I'm just showing you just so that you can learn about classification. For this, you will need Create ML, which you don't have, and not a big deal. We'll try to build something like that in the future, but let's select image classification. And you'll see that using some sort of a tool, it can become really easy. Okay, so this is all fine. I'm just creating a project. And Create ML is like a iOS tool, meaning it's a Mac OS tool. It's created by Apple, and it makes your life much easier because you can see it's all like click, click, click. I haven't really written any line of code. And it's telling me that choose your training data. So I'm going to choose the folder. I think it's called train somewhere, this one. And by reading this, it already knows that there are two classes because in the train folder, we have cats images and dog images. So they're all already two classes. And now we can just start training. That's literally it. So if I just train it, you can see it's now training the model. Okay. And accuracy is 97.1%. Okay, that's pretty good. Let's try to see if we can test the data. Now I'm going to give it like some sort of an image that it has never seen before from the test. Let's give it a cat image. No, I think not like that. I guess we have to use preview maybe. Okay, so can I add it like that? Add files. So now I'm trying to tell it that I'm trying to ask it, well, okay, what is this image? Okay, so here we go. It's telling me it's 100% cat. And if I use a different image, let's say if I go back, use a dog image. And these are the images that the model has never seen before. So it is able to predict with 100% accuracy that it's a cat or it's a dog. But this is only for Create ML is only for Mac OS developers, and it's a different story. But that is what the classification kind of looks like. You have predefined labels: dog, cat, rabbit, mouse, whatever, and you are trying to give these images to the machine learning algorithm, and it's training based on those images, which are already set up correctly or already organized in separate folders. Somebody has already done that work. And now the machine learning is basically just learning those things based on the images. All right. So that is Create ML, and we're not really using Create ML. We're using Python. So, but that is at least our the definition of classification. All right. So based on that, I have a data set over here, logistic regression, cancer diagnostic patients. So if you look at the data set, and again, this data set is created from ChatGPT, you can see the data set contains a couple of different things: age, gender, blood pressure, blood sugar level, cholesterol, and then the cancer diagnostic is 0 or 1. 0 means no cancer, 1 means you have cancer. So again, it's just 0 or 1, true or false, or some sort of a label like, have cancer, not have cancer. So that is what we're trying to classify. So if we're trying to build this kind of thing, how and where do we even get started? So let me go ahead and share it with you. Where's the chat? So you can go ahead and download this data set. It's obviously fake, created by ChatGPT, and try to see that what steps will you take if you have to find out, if you have to create a model, and if the model has to predict, given the data, if you provide all of this data to the model, can it predict that the person will have cancer or not? All right. So in order to do that, you will have to do a little bit of a different things. You will have to use train, test, split, so that you can split the data, training, and the other one, the testing. And one of those columns, if you looked at it carefully, is gender column. And gender column, the problem is all of them belongs string values. And we learned last time that it's a good idea to encode them into different things, like 1 or 0 or something like that. 1 for male, 0 for female, or something like that. So you will have to do all of that stuff. So get started with that, and then we're going to do it obviously together. But I'll give you a little bit of time, let's say maybe 10, 15 minutes, so you can do some part of it. And then I'm going to close the breakout room, and then we can do it together. All right, so let me go ahead and stop
Sounds good.
sharing. And so you will use, okay, where to go? Yeah, so you can use train, test, split, which we did in the last lecture. I don't know if you have access to the code. And in the last lecture, we also learned about label encoder that allowed us to encode the labels.
Right.
Instead of using dummy columns, I think the next time we use a label encoder, so we can use that instead of dummy columns. All right. And let me see, where's the breakout rooms? Okay. All right. Let's go ahead and try to do it together. All right. Let's see. I go back. Where are we? This one. Okay. Trying to see how we can move this around. This one, I think. Okay. The first thing, oh, it goes back, I guess. All right. Let's see if I can. There we go. The first thing we need to do is to import pandas as PD so that we have access to the pandas. And then we will say PD dot read CSV. And what is the name of the file that we're reading? Patients data. Let's read that. And we'll just read it into data frame. And then we can just look at some of the stuff. Okay. So currently when we are looking at this, do you see anything that we have to change? I mean, the data is not even in the correct format, right? Do you think that we should, or what should we do at this point before even going to and training?
You have to change the male and female to
right?
0 or 1.
Yeah.
Let
So we
me.
need to change these two things. And I think let's go ahead and see first where it comes from. Pre-processing. Okay. So that's which we have to import from sklearn.preprocessing, we import label encoder, and then we say label encoder equals to, we just create an instance of label encoder, an object of label encoder, create object of label encoder. Okay. Now, this DF or the data frame, we don't really want to mess around with that. So what we're going to do is we are going to assign this into a new data frame so that we can mess around with that.
Real quick, I don't know
Hmm?
if you meant to share your screen, but I can't see your
Oh,
screen.
oh, sorry. Yeah. I think let's see what happened. Okay, there we go. All right. So we imported pandas, we imported, and let's make sure that it says recording. Yeah. So we imported label encoder. We just use pandas to read the file. If I run this, okay, I'll probably do a df over here just to print it out. Well, now this is too much, so we'll just do a head. Okay, now we can at least see. And we have already initialized label encoder. Probably I'll just move it somewhere else, like over here. Okay. So we create the label encoder. We assign the data frame, the original data frame, to DFLE, which is just something that we can play around with without messing around with the actual data frame, which is DF. And now we can use our label encoder so that these columns, the gender with the male and female, can be replaced. So LE dot, and there's a function which is called fit transform. That is what we can use. And we can say shift tab, and we can also read a little bit about fit and transform, array like structure, like some sort of a sample that we can pass in. So we'll pass in DFLE, which is our data frame, and the column that we want to convert, so which will be gender. Now this is going to return us, let's go ahead and check out shift tab. Returns array like shape, meaning kind of like probably it's going to return series or something, like an array like something that we can assign it back to DFLE, which is our data frame, to the gender column. So the gender column will be male and female, it will be gone, and it will be replaced by whatever the transform returns. And now let's go ahead and see what is in DFLE. And there we go. So we actually got converted. 1 becomes the male, 0 becomes female. So now looking at our data, it does look like in the correct format. Every column has some sort of rows that are numbers and not strings. And now these things can be used for, for machine learning. Now we want to use the train and test split so that we can use some sort of a data for training. Let's say 80% of the data can be used for training, and then 20% can be used for testing. So let's go ahead and import. So I'll say, I think it's called from. No, let me double check it out. So over here.
That was actually one of the questions I had. So this is a really small data set. And so I wanted to, if you have a suggestion on what percentage to use for small data sets, because if you think about it, it's only going to have like 3 rows basically for training. So would it be 20%?
Yeah, so there's no correct answer to that question. I mean, some people say 70, 30, 80, 20, 90, 10. I think 80, 20 is the most common one that I've seen. Now, yes, this is a very small data set. So if you have such a small data set, well, your first job would be to get a much bigger and actual data set, because this 100 rows or even like 50, 100, even 500 is not enough. We're talking about when we want to create something that's going to diagnose something very serious, we're talking about like hundreds and hundreds of thousands, like 500,000, maybe close to 1 million. Then we can predict with a little bit more confidence that something is going on.
Right. So this is like just a hypothetical sort of test scenario. So don't worry about the percentage as of right now.
Yeah.
Because it's such a small data set. Okay.
It's such a small data set, and I think you will have to have like way more columns, like just because of age, gender, blood pressure, blood sugar, cholesterol. You can't say that this person has cancer diagnosis of 0 or 1. So there will be like hundreds of columns probably that determines that, okay, this how much white cells you have, how much the red cells you have, and what's the ratio, and all those things will play into account to kind of like guess or predict that what are the chances. All right. So from sklearn model selection, we import train test split. Now we can call train test split function. And let's see what the train test split function takes. It takes an array, and it takes a test size also. So if we pass in the array over here, maybe that will not really work. So what we're talking about is the array, which means we're going to be passing in like the data frame, which contains of this thing, I guess. But we need to remove this column from our data because that's not the column that we want right now. So we need to do something about that. So let's go ahead and see if we say dfle dot drop the column, and the column name will be this one, diagnosis. Axis will be columns, and it assigns it back to the DFLE. So let's see DFLE again. Okay, so now it doesn't really have that column because that's a column that we want to predict. So now we can probably use this function, which is train test split. Let's see what we are passing. I keep going over there. Let's see. X and Y. Okay. Now you can, since we're going to pass X and Y, I usually like to just create a variable, capital X, uppercase X, and then Y. So this X will be the whole thing, which is pretty much the whole thing over here. So I can say, I guess it will be DFLE, and Y will be the only column that contains the actual result. So it will be this column. Now, where are we gonna get this column? So probably I shouldn't have deleted that column. We can not really use it. So let me see if I comment this out. Actually, we do have to delete that column anyways, eventually. There are multiple ways I can do that. Let's go ahead and do that. And let's do head. Let's run it again. Okay. So in X, we can say dfle.drop. So now it's only going to assign the correct thing and access columns. There we go. And Y will be just a DFLE, but with this column name. There we go. And we can pass an X and Y. This is going to return us X train, X test, Y train and Y test. So it returns like 4 things: X train, X test, Y train, Y test. We do have to also specify the test size. And we can say 0.2, which means 20%. So 20% of the records will be, the rows will be used for testing, and what is it, 80% will be used for training. Okay, it's already separated it out. Let's go ahead and check out the length of X train. This is for training. Okay, so the X train is 12. What about length of X test? Should be 4. So 80%, 20%. All right. So now we have our X and Y. Now we can create, our logistic regression. So let's go ahead and import logistic regression. And model equals to logistic regression. We're just going to initialize it. I think the good thing about this sklearn is that whether you're using linear regression, logistic regression, nearest neighbors, whatever, the interface is kind of like the same. You create the instance and then we call the fit function. We pass in the X and Y. So X train, Y train, and next we finally, it's already trained. Now we can go ahead and predict. And I believe we have to pass in the data frame. So let's see what we have to pass in over here. Age and then gender. So let's pass age of 65. And the gender is 1 for male. Blood pressure, okay, 160. Blood sugar and cholesterol, so 130 and 250. 0. So 0 means that this person, whatever we're passing, it does not have cancer, or at least the diagnosis was not cancer. You will have to play around with this to get the actual thing to be a little bit different. You can see most of them are coming out to be not cancer. 260 maybe. Some of them you'll see that they will have cancer, but again, it's kind of hard to get to that point. Yeah, but there will be something that will say that, okay, this person will have cancer. Yeah, I can't really get to that.
Yeah, it's like with the numbers, it's hard to see I don't understand the pattern either because of the limited data set, I guess. It's hard to figure out which you should put in.
Yeah, even if I put in, let's say 62, 1, 150, probably it's 62, 1, 150, and then 130 and 250, 130 and 2. Yeah, there's no pattern right now. Okay, so there we go. But if I put it like exactly the same one, it actually shows me that, okay, it's cancer. Now, if I change the date over here, okay, I mean, 63, still cancer. So what led to that? What is causing cancer is very hard to see right now. It can be a couple of different things, but it's kind of hard to see what's going on. All right. All right. Any questions regarding this?
Nope. I pretty much did the same thing. Only thing I messed up on was I didn't make a new data frame when I was converting the label encoder. I just kind of put it on the original column of the original data frame for gender. Yeah.
Okay. I mean, yeah, I guess in this case, even if you did it on the original, it should be okay because you're not really using the original down the road. If you were trying to say, oh, I wanted the gender column male and female, then you're like, okay, now I have to go back and do something else. All right. Now, the other thing that we should go over is the same thing, the logistic regression, but using handwriting. So handwriting and how can it detect, how can the logistic regression tell us that if I've written something like this, it's 2, and if I've written something like this, it's 4. So, but the question is, where do we even get the data set of handwriting data set? The good news is that, oh, here we go. The good news is that it's already available in scikit-learn. So let me go ahead and see where we can import that. So scikit-learn already has some built-in data sets that we can use. And one of them is called, just like the Boston data set, which was not working, but this one is scikit-learn.datasets import load digits. So load digits is a function that is going to give you that data set. So it's kind of cool that scikit-learn already has these small data sets that you can use. We're going to put it in digits. And let's go ahead and print out what the digits are. And if you call the load digits function, it's going to return you an array of something. And if you print out load digits, you'll see that it prints out the data, which is in the form of an array, and then pixel, pixel, something. You can also use dir. Now, dir over here, it means you're just getting a description of all the properties that are available in digits. So that's kind of like a cool property, the cool function that you can use to find out what properties are in this object, which is really helpful. All right. So let me actually reply to this person. What's going on? All right. So load digits is a function. Load digit is a function that is, we imported it from sklearn.dataset, and it's going to return us an array of objects, and these objects will represent digits, like somebody has handwritten digits, 0 through 9. And if I say dir digits, it can give us all the properties that the digits contain. So let's go ahead and check out some properties like digits dot, if I say data, you'll see, I mean, you can access the property like this also. I usually like to use like this. Okay, digits, what is digits? Well, it's more like an array of the two-dimensional array of numbers just going on, all right? What about images? Okay, so images is also kind of like this. But the good thing is that we can actually render these images so that you know what it looks like. All right, so let's go back over here. And I think what we can do is we can use this function. I don't know if I've imported matplotlib over there or not. No. All right, so let's import matplotlib because we can actually use matplotlib to see what those things are. So we'll go ahead and import matplotlib.pyplot as PLT. All right. And I guess we'll also say inline matplotlib inline. And now we can call a function which is matshow and see what's on the array of index of 1. Now it kind of looks like this. Kind of hard to see what this is. So you can also change this to plt.gray so that it only shows you kind of like a gray. Okay, so here's what the number is on 0. Now this is 0, by the way. So if I say 1, see that? It's 1. Kind of hard to see, but it is 1. This is 2. And it goes till, like, it's a pretty big array. of digits, like if I go ahead and see length of digits, well, it's only 7, I guess, but the digits itself, the digits of data, let's see what's how many records. You can see 1,797. So 1,797 items are in the array, which are either 0, 1, 2 till 9. So that's what is in the array itself. Right? Any question at this point?
Wait, I don't understand. So what do you mean by items in the array?
Yeah.
So you're saying for index 2 within images?
So yeah, so digits is an object that contains properties, which are all of these properties that we printed out. And one of those properties is images. So if I say over here digits, which is basically an object, and give me the access to images, right? Now, if I length, like if I see how many images are there, because images itself is an array.
Okay.
Yeah.
I got it. Yeah.
So 1,797. Now, if I say, I think the another property is target. I'm hoping the target should be same, because target means, well, these are the images. In the images, it's images. Target means whether it's 0 or it's 1. So there we go. So you can see you have 1,797 images and 1,797 target. Target simply means that if that image is a 0 or 1. So if I say
right, I got confused because the length kind of threw me off. I was like, oh, that's a lot.
Yeah. So if I simply say, did I do something wrong? Digits of target. Oh, length, not length. Forget the length part. If I say 0, so digits target basically means it's number from 0 to 9. And on the 0 location is 0. Let's check out the image at that location. I think we already did, but images on 0 location is, well, kind of prints it like that. But if we show the image using this technique and just change it to 0, it's also 0. So that means that they're arranged in a correct order. On index number 0, there is 0, and then the target on that particular index number 0 is also 0. And I think if I press do 1, it's going to do the same thing. On 1, it's 1, and on image is also 1.
Do those arrays represent like the colors on each block? I'm just asking. I don't know.
Yeah. Well, the color on each block is represented by the data. So if we print out the data, and it will be a little bit hard to see because it's an array of numbers. So if I say data of 0, so you can see these things over here. So this is kind of like the values of the colors on these particular spots, which makes the 0, I guess. Yeah. Now, we still haven't done any training. I mean, we just have this target, we have the images. So let's see how we can train. Yeah, so we're going to use the same thing, X test and train. Here we go. Train test split. X-axis will be the data, which is array of numbers, which represents the image. And on the Y is the target. Target contains the labels 0, 1, 2, 7, 8 till 9. And now we can actually go ahead and train it. So now we have X train, X test. Oh, I think we forgot to add over here the test size. So probably we should do that. Not sure what will be the test size if I don't specify it. There we go. And we have X train, and then we have X test, Y train, Y test. Let's go ahead and print out the model. Model is still logistic regression, that's fine. And now we can do X train and Y train. Now we are training. Now we are training part of it. Let's see. Okay, so this is the error that you're going to get, which is number of limit has reached. So what's going on is that when it's trying to train, it needs to do more iterations. Without more iterations, it's not able to train correctly. So for that, what I'm doing is somewhere I'm setting the training. Okay, so I'm doing this part. I'm just trying to set the maximum number of iterations so it can train it really nicely. There we go, maximum 9,000. So now it's going and then it's probably training is finished at this point. There we go. It took a while actually, but now it is finished. So if you don't pass maximum iteration of 9,000 or something bigger, I think it has to be bigger than 1,000, then the training it will just time out. It's not going to be able to train. Now finally we can find predict. And what should we pass in the predict? Well, let's go ahead and see how we're predicting. We're just going to pass in the data. So it will be X train of data. Let me double check it over here. And digits actually, not X train. So digits, data 56, and it returns us 1, which is basically telling us that it's saying that the prediction for this image is 1. Okay, let's see what this image is. Where is our graph? And we're talking about 56, right? So let's go ahead and pass in 56 just to see what the graph will print. Yeah, it's 1. So this means that our prediction is correct and it is predicting pretty good. We can always say model.score and we can pass in, I think if you pass in X train and Y train, it will even tell you that the score is 100%, meaning it's very accurate. It's 100% accurate, basically. So that is how we can do training as well as prediction for handwritten digits, I guess, using built-in digits which are available, through the scikit-learn.
So it trains it by turning like an image into an array of like a multi-dimensional array of like color blocks.
Yeah.
And then sort of guessing where the color blocks should show up.
Yep.
Okay. That makes sense.
Yeah. Yeah. So it's basically checking the alpha colors. Like you can see over here, it's a little bit different on the top, right there. It is a little bit dark. So it's keeping track of, when it's training, it's keeping track of, for number 1, the looks like on the top left corner, or even if it can be like this one, like this is all dark. All of this is dark for number 1. But if I say number 2 over here, you can see parts of this are now covered, like this part. So it's keeping track of what color alpha, I guess it's being used, like 0 to 55. I think white is 255. So this will be granted like white color. And depending on like this gray color, whatever the actual RGB color value is, that will be assigned to this. And that's how it's keeping track of the array with those, those numbers, array which contains all the specifications. Yeah.
Okay. Right. Last question. I know it's past your time, so I don't want to keep you, but can you explain to me just real quick the iterations, like what they actually do? Because I know
Yeah,
you said
so
you have to have a minimum amount.
yeah, if you don't put iterations, then you already see it give you some sort of an error. So let's say if I do something like this, then it comes out with that stop total number of iteration reached limit. So iterations basically in this context, it means that it's trying to create paths, like a path to go while it is training that, oh, this path leads me to one, this path leads me to 1, 0, or 0 or 3 or 4. And it just doesn't have enough iterations to find those paths or to calculate all of them. So that's why we are passing in some sort of a number over here. It doesn't have to be 9,000. I mean, we can try with 1,000, but I think 1,000 is let's see. Sometime it works, sometime it, okay, see it after that it kind of fails. So we can try with 2000. Probably 2000 will, nope, not even with 2000. So maybe 5, 6,000 might be the correct one. It just has to get more iterations so it can locate, it can find out that that number was something. There we go. So it works with 4,000 also. Yeah. All right. So that is pretty much it for today. Let me see over here. Logistic regression. Okay. Not sure what happened. Let me see, where is that file? Okay. Our file, well, that's a little bit different file, but although it's called linear regression, but I think that's the one. So this is, well, I think we did save it right there. Okay. And okay. So that is a Jupyter notebook that you can use. All right, so that is pretty much it for today. And tomorrow we're going to look at some other stuff, probably with like a nearest neighbor, or we're going to do some activities also. So, and you can also always look at I think you already have the GitHub link. Let me actually see if you have that GitHub link, because it does contain some uh, non or ungraded things that you can take a look at. Because I think right now you are working.
Oh, I forgot. I'm sorry. I forgot to send you the GitHub links to the exercises that you
The
told me. So
exercise.
I'll
Okay.
send those to you
Yeah.
this evening.
Yeah.
Sorry.
And you can save that link, the one that I sent you, because that contains like all of them. Uh, and I mentioned the practice exercise module 1, module 2, module 2A, 2B, 3A, 3B. The other ones are there, but that's like for class activity. But I think for 2A, I believe, it's more of a relational database. You don't really, yeah, it's more about SQL and all that stuff. I'm not sure why SQL or what is SQL doing in the course itself. It doesn't really fit in correctly, I guess, but it's based on the labs that is assigned to you, like the actual lab in Canvas. So, but the one that on GitHub, they're ungraded, but you can still submit those things.
Okay, sweet.
All right, then I will see you tomorrow.
All right, see you tomorrow. Thank you.
All right.